Welcome back to tomorrow's update. Today, we're exploring an exciting development at the intersection of artificial intelligence and robotics, physical AI. This term refers to the integration of AI into machines that can interact with the physical world, enabling them to perform complex tasks with a level of autonomy and adaptability previously unseen. Traditionally, AI has been confined to the digital realm, excelling in data analysis, pattern recognition, and decision-making within virtual environments. However, the real world presents a myriad of unpredictable variables, dynamic environments, physical constraints, and the nuances of human interaction that require a different approach. This is where physical AI comes into play, combining the cognitive capabilities of artificial intelligence with the physical adaptability of robotics. A prime example of physical AI in action is the development of autonomous vehicles. Companies like NVIDIA are at the forefront, creating advanced AI systems that enable cars to navigate complex environments safely. NVIDIA's CEO, Jensen Huang, has highlighted the potential of physical AI, introducing platforms like Cosmos to accelerate the development of intelligent machines capable of understanding and interacting with the physical world. In the realm of manufacturing, physical AI is leading to the creation of more adaptable and intelligent robots. These machines can learn from their environments, adjust to new tasks, and work alongside humans safely. This advancement not only increases efficiency, but also opens the door to more flexible production processes, where robots can be reprogrammed or can learn new tasks without extensive reconfiguration. Healthcare is another sector poised to benefit significantly from physical AI. Imagine robotic assistants capable of performing delicate surgical procedures with precision, or autonomous devices that can navigate hospital environments to deliver supplies, monitor patients, or assist in rehabilitation exercises. The fusion of AI with physical devices in healthcare promises to enhance patient outcomes and alleviate some of the burdens on medical professionals. However, the rise of physical AI also brings forth important considerations. As machines become more autonomous and capable of interacting with the physical world, questions about safety, ethics, and the impact on employment arise. Ensuring that these technologies are developed and deployed responsibly is crucial. This includes implementing robust safety protocols, establishing ethical guidelines, and considering the societal implications of widespread automation. In conclusion, physical AI represents a significant leap forward in the evolution of technology. By endowing machines with the ability to perceive, learn, and act within the physical world, we're moving closer to a future where intelligent systems can assist us in ways previously thought impossible. The potential applications are vast, and while challenges exist, the promise of physical AI to transform industries and improve lives is undeniable. Thanks for watching, and see you in the next one.